Alright, continuing with section 4.3, applications of systems, we're going to look at a couple more examples of real-world situations where we need to set up the system in order to solve and find some specific variable. And here we're going to actually get into some examples where we do need 3 equations and 3 variables in order to solve. So let's look at our first example. We have a situation. An airplane took 3 hours to fly 2,100 miles against a headwind. The return trip with the wind propelling the plane took 2 hours. Find the speed of the plane in still air and the speed of the wind. So, first of all, the 2 things we're trying to find, that's what we always want to set our variable as. So, we want to know the speed of the plane in still air and the speed of the wind. Those are the 2 things we need to find. So let's let our variables represent that. So we could use P to represent the plane speed. In still air. And then we could use W to represent the speed of, speed of the wind. Okay. So those are the 2 things we need to find. However, we need to use those to create some expressions that we're going to use in the problem. So what we can do here is take this. The plane speed with the wind is going to be when the wind is aiding this plane, making it go faster, then the actual speed of the plane would be however fast it was going plus however fast that wind was blowing. But when the plane was going against the wind, then the actual speed that it's going would be its typical speed, but we have to subtract however fast the wind was going, so P minus W. So if P plus W with the wind, P minus W to represent how fast this plane is going when it was going against the wind. Okay. So this problem does deal with distance, rates as speeds, and time, so we're going to need to use that formula, the distance formula, to kind of set up our system. So let's recall that the distance formula, distance is equal to our rate, our speed, times time. How long were you traveling that speed? Okay. So let's see what we can set up from the problem, what we know. Well, first of all, we know on the trip against the wind, it took 3 hours to travel the 2,100 miles. And again, that was going against the wind. So we can set up an equation in our distance equals rate times time setup. The distance traveled we know is 2,100 miles. That's going to equal rate, our speed. Well, when we were going against the headwind, our speed would have been P minus W. And times time, how long were we going that rate? 3 hours. So times 3. We can then use another equation representing the plane ride back. The return trip with the wind propelling the plane took only 2 hours. Okay. So that formula would look like 2,100 equals P plus W times 2 hours. So distance equals a rate of P plus W since it had the aid of the wind at its back, and that trip only took 2 hours, so times 2. Alright, so the way these 2 are looking, well, we could go ahead and multiply the 3 into this parenthesis, the 2 into that parenthesis. Come over here and do that. So we actually have an equation 2100 equals 3p minus 3w, when we distribute the 3. In our other equation, we have 2100 equals 2p plus 2w. Alright, so there's our two equations. The way it's set up, this looks like a nice example to use elimination. We have our two variables both on the right-hand side of the equation. We have our constant on the left-hand side of the equation, being 2100. This one is set up perfectly for elimination. So, I suggest we do that. So in order to use the elimination method, we have to try to cancel out either the p's or the w's by adding or subtracting. Right now, the coefficients of the p's and the w's do not match each other. So we're going to have to multiply one or both equations by something. We can't multiply 2 by something to turn it into a 3, so we're going to actually have to change both equations. We can turn both the 2's and the 3's into both will multiply into 6. So we can take our top equation here, multiply every term in this equation by 2 to get a 6p and a 6 minus 6w, and then this bottom equation we can multiply everything by a 3 also to get a 6p and a 6w. Alright, so doing that, I'm going to come over here now. Multiplying everything by 2 is going to give us 4200 equals 6p minus 6w. And multiplying 3 gives us 6300. The next equation equals 6p plus 6w. Alright, so now we're set up nicely. We can either add or subtract to cancel out. If we subtracted, the p's would cancel. If we add right now, the w terms would cancel because they're opposites. So at this point, why don't we go ahead and add them? Cancel out the w terms. Okay. 4200 plus 6300 gets us 10,500. And the w's will cancel, and we're left with 12p. Alright, so now we can solve this equation for p, dividing by 12 on both sides. And we get the speed of the plane is 875 miles per hour. Equals p. Okay. And yeah, keep in mind that is in miles per hour. So p represented the plane speed in still air. Now we can use that and go back into, I guess, either of the two equations to find out what is the speed, the speed of the wind. So looking back, again, either of the equations will work. I would say probably use this. We could use one of our two original equations, or we could use one of the two new equations we found here. It really doesn't matter. Let's just bring this up here. I would say use one of the original equations that you had created. So let's use this 2100 equals 2p plus 2w. Let's use that equation. Okay, smaller numbers, maybe a little bit easier. So, substituting in what we now know, our p value is 875. So, 2100 equals 2 times p, which is 875 miles per hour, plus 2w. Multiplying there, 875 times 2, we get 1600 plus another, 1600 plus another 150, so 1750 plus 2w. We then want to subtract 1750 from both sides and divide by 2. So subtracting 1750 from both sides, we should get 350 equals 2W. And divide both sides by 2. And we get that the wind speed was 175 miles per hour. All right. So now we found both pieces we needed for that problem. And just every time we set these equations up, elimination oftentimes will work best, but sometimes substitution will work best. You just always have to decide based on how your equations look. That one will obviously work best for elimination. All right. Let's slide this up now. Take a look at the next example, dealing with the perimeter of a triangle. So we have the perimeter of a triangle is 53 centimeters. So that's the distance around the triangle. And every triangle, of course, has 3 sides. So adding up the 3 sides of the triangle gets us 53 centimeters. The longest side is 3 centimeters less than the sum of the other 2 sides. Okay? And then twice the shortest side is 11 centimeters less than the longest side. Find the lengths of each side. So this is a little bit tricky, but they do tell us in the last sentence what we need to find. We need to find the lengths of each side, the short side, the long side, and the middle side. So let's use our variables to represent that. L is going to represent the length of the long side. M will represent the length of the medium side. And S we can let represent the length of the short side. Okay. So using the equations, or using what we know from the problem, let's set up some equations. First sentence, the perimeter of the triangle, we're told right off the bat, is 53 centimeters. Okay. Well, that means that we could set up the equation, the long side plus the middle side plus the short side is going to add up to 53. Okay, equals 53. That's how you would have found any perimeter of any figure, just adding up the sides. So there's one working equation we can use. Next sentence, the longest side is 3 centimeters less than the sum of the other 2. So longest, 3 centimeters less than the sum of the other 2 sides. Okay, so that means if we were to sum or add the other 2 sides, the longest side is going to be 3 centimeters less than that. So we can set up an equation like this. The long side is going to equal the sum of the other 2 sides. That would be the medium plus the small. That gives us the sum of those 2 sides, but the long side is 3 centimeters less than that. So it equals their sum minus 3 centimeters. So there's equation 2 we can use. Now looking at equation 3, or setting up equation 3, twice the shortest side is 11 centimeters less than the longest side. Okay. So last equation we can set up, twice the shortest side, that means 2 times the shortest side. So 2s is going to equal 11 centimeters less than the longest side. So it's going to equal the longest side, but then 11 centimeters less than that is going to be minus 11. So there's our third equation we can set up. So now we can look at this and determine some options we have to solve this problem. From here, I guess your decision is what method would be best to solve. Substitution we could possibly do because we have one equation already solved for L. So we could go back up to this top equation, and instead of L we could replace this L here with M plus S minus 3. But then we still have M and S, then we still have 2 variables. in the problem. And we need to cancel, we really want to get it down to a single variable problem. Over here we could solve this equation for L as well, adding 11 to the other side, but again, if you replaced this L with whatever we get over here, I mean, we're still going to deal with equations that have two variables, and that's not going to help us. So really the best way would be to do elimination. However, we need to get this into standard form before we can do elimination. Okay? So that's what I'm going to write over here. Put in standard form so we can use elimination. So looking at our three equations, standard form is going to be when we have the variables on the same side, all on the same side. In this case, we can put them all on the left side, and then our constant term on the right side. So equation 1 is pretty much already set up that way for us. We have L plus M plus S equals 53. That one's fine. The other two equations we're going to have to manipulate a little bit. So, looking at our second equation, M plus S minus 3 is all on the right hand side. We need to move the M and the S over to the left hand side. When we do that, since they're both positive here, we would be subtracting them. So it would become, we have a positive L already on the left hand side. We move an M over, it would become a minus M. We bring a plus S to the other side. We do have to subtract S to get rid of it. And then we keep the minus 3 there on the right hand side. And then doing the same with the bottom equation, we already have the S, a 2S there, so that's going to be a plus 2S here. We bring the L over to the left hand side, it's going to become a minus L. And we didn't have any M term in this equation, so usually I like to still put a 0M in place there, just showing, just so that we have our L's, M's, and S's all line up in columns. And that's going to equal the negative 11 that was already on the right hand side. So just kind of to back that up, any time the variable is already on the left hand side, it's going to remain the same sign. L stayed positive, 2S stayed positive. But when we had to move things from the right hand side to the left hand side, that's when they became negatives, here, here, and here with the L when we had to move. So now we have our equation in standard form. We can do elimination. We can call this equation 1, equation 2, and equation 3. We have a 3-variable system. We're going to have to do elimination doing the long way of elimination, using the 3 variables. However, this one's set up nicely where it won't take as long. So we want to look, the way it's set up right now, we could add equations 1 and 2 together right off the bat, and not only are the M's going to cancel, the S's will cancel as well. So that's the best move we want to do. We could add equation 2 and 3 because the L's will cancel, but then we'd still have an M term and an S term, and that would take a longer process. So adding equations 1 and 2 is going to be our best option. It's going to get us to the answer the quickest. So if we keep equation 1 and equation 2 as they are, L plus M plus S equals 53. Equation 2 is L minus M minus S equals negative 3. And because they're already opposite signs, we do want to add in order to cancel those out. So we can come here. That's going to give us 2L when we add. The M plus a negative M, S plus negative S, cancels. And then 53 plus a negative 3 gives us 50. Okay. Here, if 2L equals 50, then we would divide on both sides by 2 and get that the length of the long side, L, is going to equal 25. And 25 what exactly? Well, we're dealing in centimeters, so 25 centimeters for the long side. Okay, well, if we know that, we can use that in order to find the other two. So I'm going to bring this over to the next page of the notes in order to finish. So remember, the length of the long side is 25, and we're going to be using equations 1, 2, and 3. So maybe I'll just slide this down. We'll finish this problem at the top of this page. Okay. So, plugging 25 back, which equation would be best? Well, we could go into the original equation 3, right here. Or even equation 2, no, 2 solve for L. So, this only has 2 variables in it, so we could quickly find out what S is using this equation right here. So, why don't we do that? We can call it the original equation 3, which is 2s equals L minus 11. And we now want to plug in 25 for L. So we would get 2s equals 25 minus 11. Subtracting 11 gets us 14. So 2s equals 14. Dividing by 2 on both sides, we get that the short side is equal to 7. So the short side is 7 centimeters. And then lastly, we can use that and the fact that the long side is 25, going back to either of your equations. Now we need to find the medium side. So we can go to equation 1 here that has length, long, medium, and short, all in the same problem. So we'll call that equation 1. Okay, long plus medium plus short equals 53. This is now going to allow us to find the medium side. So our long side was 25. Our medium side was, we don't know. Our short side is 7. It's all got to add up to 53. 25 and 7 gives us 32. So 32 plus m equals 53. That tells us the medium side, m, has to be 21 centimeters, subtracting 32 from both sides. So now we have our 3 side lengths, add them up, 21, 7, and 25. It does add up to give us 53. And that is all we'd have to do for that problem then. Okay, so you see some of these examples will require 3 variables, 3 equations. That's why we did learn this whole elimination process with 3 equations. Okay. One more example now to finish up on the same page here. We have this Nike Shox example. So we have Nike's 3 best sellers are Jordans, Air Forces, and Shox. One day at an outlet store, 15 more Shox were sold than Jordans and Air Forces combined, and 4 times as many Air Forces were sold than Jordans. 315 total pairs were sold. How many of each type were bought? Okay. So first of all, we know 315 total pairs were sold. So that is going to be able to, that right there tells us one of the equations we can set up. I guess in this problem, we are trying to find out how many of each type were bought. So our variables need to represent how many Jordans, how many Air Forces, and how many Shox. So I'm going to use J for Jordans, A for Air Forces sold, and S for Shox. So if 315 total shoes were sold, then we know the Jordans plus the Air Forces plus the Shox had to add up to equal 315. Okay? So there's one equation. Another equation we could set up, let's look at the second sentence. 15 more shocks were sold than 15 more shocks were sold than Jordans and Air Forces combined. Okay, so let's underline that. That means if you add Jordans and Air Forces together, the shocks are going to equal that plus 15 more. So we could set up this equation. The shocks equaled the Jordans plus the Air Forces plus an additional 15 more. Okay. And then lastly, 4 times as many Air Forces were sold than Jordans. So the Air Forces are going to equal 4 times however many Jordans were sold. Okay. So 4 times as many Air Forces were sold than Jordans.